Today we're going to repair the Trio power supply. Here's the section of circuit that we're going to be working on, and this is on the AC line input board. And what usually happens is that these four resistors will open up, and they will prevent the AC from being rectified, filtered, and applied to the 78M12 three-terminal voltage regulator. Here's the white connector where the AC is applied to the board. There's the rectifying diode, and these are the filter capacitors on the input and output of the 78M12 voltage regulator. This is the regulator right here. And here are the four surface mount resistors that open up. They're 1 ohm each in parallel. Let's take a look and see what they measure like right now. Well, I don't think that's 0.25 ohms. That's a little bit high. There's 6.12 kilo ohms right there across those resistors. It's a little bit too high. 1 ohm divided by 4 is 0.25 ohms. I'm going to use this 0.27 ohm 3 watt resistor to replace those 4 open resistors. We're going to drill a couple of holes to allow us to mount that resistor. Now, don't worry, there's no traces here that I can cut through with that drill. Now, if I had enough room between the board and the wall of the housing, I'd mount it on the other side. But since there's no room between here and there, we're going to put the resistor on this side and connect it, solder it to the other side of the board there. We need to join the white connector, the 2-pin white connector, to the rectifying diode with our 0.27 ohm 3 watt resistor. Here I'm going to connect one side of the resistor to pin 1 of that input connector. The input connector is connected to a secondary of a switching transformer. Don't burn your fingers, Peepaw. I try not to. There we go. One side of the resistor connected to pin 1 of the connector. Now we're going to connect the other side of the resistor to the anode of the rectifying diode. Here we go. We're going to use this red jumper wire over here. Trying to figure out how I'm going to route this wire. Which way do I want to go? Alright, let's tin our wire. It'll make it easier to attach to the anode lead of that rectifying diode. And a little bit of solder there. There we go. Let's bend it around the corner. That red wire connected to the anode of the rectifying diode is now going to be connected to the other side of the resistor. There we go. The hard part's done. Let's see if we have continuity. There, meter. Where you at, meter? Come on. Time to go to work. Oh, I'm upside down again. Okay. There's the anode of the rectifier to pin 1. What we got there? 0.5 ohms. 0.2 ohms is my meter lead resistance. So 0.5 minus 0.2, 0.3 ohms. That's close enough to 0.27. And again, there's the circuit that we just worked on. Those 4 parallel ohm resistors. Now you notice we didn't remove the resistors, but since they were opened up, there was no need. They weren't going to get in the way. All right, let's see if we can get this thing back together, power it up and test it. All right, now don't forget the plastic insulators. We don't want the high voltage and low voltage to get in contact with the metal housing. That would be disastrous. And you see those insulators there on the floor plate. Don't forget those. Now I don't have quite the right Torx, so the one I have is just a hair bit smaller than the Torx slot in the screw face. So it's a little bit iffy going in. I need to run up to the hardware store and get me the right Torx, but we ain't got time to do that. Let's go with it. Let's go with what we got. Now we're installing the board that we just repaired. All right, one board installed. Don't forget the plastic spacer. That insulates us from disaster. Okay. There it is. Okay. There we go. We're halfway there. Yep, look, I dropped the screw. I gotta get me a new set of Torx. These bits that I've had forever. I don't have a complete set. Need to run up to the hardware store and get me a few more Torx. Just to keep up with modern times. Alright, now the fun part. Trying to get my small hands into this small area and try and connect everything up. The two boards have to be connected together. And I just don't have enough room in there to make it easy. Especially this one connector here. This connector connects the IGBTs to the switching transformer. The IGBTs are on one side of the board, the switching transformers on the other side of the unit. So you got the switcher over here on one side and the switching transformer on the other side. And they go together with this one connector that's down there in the middle. You know, next time I might just connect the two boards together before I set them down in the housing. But when I do that, I can't get those plastic insulating spacers properly aligned. So we might do that next time. We'll see. Right now, we're just going to have to struggle. Are we there? We got it? Let's take some pictures. I like to take pictures of the things I'm working on. That way when I'm old and gray and falling apart, and my children can look at the things I used to work on. They'll say, well, great-great-grandpa, he wasn't too stupid. Okay, this is the part I hate, and I'm going to cut this short so y'all don't have to watch, but I've got these clamps compress the power devices, the IGBT and the diode power devices, down to the floor plate heatsink. And they are a pain to install, and I just don't like doing this. Has to be done, but I don't like doing it. So we're going to cut this a little bit short. We're only going to do one side, not both sides, in the video. And I'm going to cover up the process with my hat. Oh, Lord. I'll get my big head in the way. The problem with these clamps is you got to reach down inside, place the clamp inside while trying to tighten it all down with the screw that's on the outside between those fins, between the heatsink fins. Not an easy process. I often wonder how the folks in the factory that put these things together, I wonder how they do this, because I have a hard time. Just a couple more to do. Last one. I did the other side earlier off the video. I turned the video off. I didn't want y'all to hear me cussing. The other side was the hardest. This side here is the easiest. See, you got to run that screw through the fins of the heatsink assembly and run that into the clamp, and the clamp holds and tightens the MOSFETs and diodes down to the heatsink assembly for a proper heat transfer. Whew. Oh, that was hard. Well, let's install the cover. I always have a problem lining up the Power OK LED with the hole in the cover. It takes me a little bit to get that right. Almost there, folks. Almost there. Now, did you notice that I'm putting the cover on before we've tested this thing? I usually don't do that. I'll usually take and test things before I install the cover, but I feel really, really good about this repair. Those 4 parallel open 1 ohm resistors were definitely a problem, so I feel really good about this repair. There we go. We're going on with the cover. Now we're going to attach the cover to the heatsink assembly. I'm using a pick to line up the screws. This cover doesn't always want to line up correctly with the screw holes in the heatsink assembly, so I try to pry things over with the pick. Here goes the second screw. That's one side. Let's go to the other side. Lastly, let's install the DIN rail mount. This will complete the assembly process. Okay. Now we're going to hook up the 380 volt AC 3-phase line to L1, L2, and L3. We'll throw the smoke at it. That brick right there is going to keep the cable from pulling this unit off onto the floor. Now don't worry none. We're not hooked up to the power plant yet, so the 380 is turned off. At this point, did I get a little bit nervous about whether this thing is gonna go south and explode on us, or if we're gonna be okay and successful in our repair. You don't never know until you turn the high voltage on whether things are gonna go good or bad. Usually when things go bad, they go real bad. So wish us luck. Wish us luck. Here we're going to use two parallel 10 ohm 230 watt resistors to load the output down. This power supply is capable of sourcing 40 amps, and we're not even going to get close to that with this 5 ohm resistor. The most we might pull is 4.8 amps. That's 24 divided by 5 ohms. 24 volts divided by 5 ohms equals 4.8 amps. Let's connect our voltmeter to the output. Okay, next we're going to apply 380 volts AC 3-phase to L1, L2, and L3. There we go, look at that. We have 26.45 volts DC at the output. And the green DC OK LED is on. All right, all. You fixed another one. Awesome job. That's wonderful. All right, all. Thank you very much for coming by and watching us fix something else. It's always a pleasure when you all come over here to see what we're doing next. We'll see you in the next one.